In this recording, I'm going to talk about a reflection agent, and then we'll see how we can implement a reflection agent using Langgraph. Now, what is reflection? So it's a prompting strategy, and the prompt lets the language model reflect on its past action, critique it, and then try to improve the response or improve the next response, right? And then if it is critiqued again, then it try to further response it based on how many numbers of multi-turns you have programmed. It is similar to our system two thinking, which has been elaborated in the book Thinking Fast and Slow by Daniel Kahneman. It's a very interesting book. So yeah, if you get chance, read that book. Let us now build a simple reflection agent and see how we can make it work using Langgraph. So this is the code, and the requirements like a Langgraph python.env, langchain OpenAI. And here, so this is where I get so I use OpenAI, or this is my OpenAPI key. I instantiate the LLM using the LangChain abstraction on um, of chat OpenAI, which the default model used is GPT 3.5. And then I create a state class. Now, this is the state, this is the shared state. So Langgraph, what it does, it orchestrates multiple agents together, and it also provides a shared persistent layer. Like yeah, you can make it persistent. In this example, I have not persisted it, but it gives a um, shared persistence or a shared space or shared state that can be um, modified by all the agents in that who are participating in that workflow. And in this particular program that I have written, this is the shared state that I have created, which is consisting of the messages attribute, and this is the message, so which is a list of base messages, and all the agents who are interacting in this workflow will keep adding to this state, this message state, as they execute their functions, right? So now let's look at the agents that I have created. So first one is a generate agent. And what I'm doing here is I gave it a generation prompt where I said you will answer based on a question asked. Please ensure to add all necessary details. If you receive a critic, and we'll see how we pass the critic through the critic agent. If you receive a critic, respond with a modified version of your answer or a response that incorporates the critic comments, right? And then I use LangChain expression language to create the LLM chain. And then I invoke the LLM chain, passing the messages. So this messages is nothing but the the instruction or the question that the user will ask that will be added to the state, the shared state again. There I take the messages which has a question and give it to the generation or the generate chain, right? And then whatever that chain returns, I return it. When I say return messages dot content, this particular piece of code is going to update the state. It is going to add that message to that state, right? And then the critic answer is the critic agent is coded in a similar way, where I gave it a reflection prompt where I said you will be grading a provided answer, generate critique and recommendation for the user submission, provide detailed recommendation including request for length, depth, style, etc. And then I am creating the chain, reflection chain. I am getting the original question now. The original question will be in my state, shared state again. So the first message in the shared state is the original question, right? This is the original question. And as the critic is giving a response, the critic response will be appended then to the generation agents respond, right? But the original question will always be the first message, and the last message in that shared state will be the latest answer given by the generation agent. So that's what I'm capturing here. So the original question and the latest answer that is given by the generation agent is what I'm giving to the reflection agent. So this is nothing but concatenation of the original question and the answer provided by the generation agent. It goes into this message, right? So it is you'll be grading a provided answer. So this has the answer, generate, critic, and recommendation for the user submission, right? And whatever message the reflection agent or the reflection chain gives me, I append it again to the shared state, right? And this is where I check when to, after how many iterations I should stop this back and forth between the general agent and the reflection agent. So here I put a very simple logic. If the length of the shared state, the length of the messages, which is a list, the shared state is greater than 8, that means four interactions, right? Because in each interaction, you have two messages, one for the generate agent, one from the critic agents. After this, just end it. Otherwise, return the critic agent. It will continue, right? And this is where I make the workflow. I create an instance of the state graph with the state. This is my state, right? And then I add the generate agent node, the critic agent node. My entry point is a generate agent. I add a conditional edge. So generate agent, this is the conditional agent. So after generate agent generates the response, it will see if the state message is greater than 8. If it is greater than 8, it will end. Otherwise, it will pass to the critic agent, right? And yeah, and then there is a edge from the critic agent to the generate agent. I compile the graph, I return the graph, and then in my main, I instantiate the class, reflection agent class, make the workflow, and then in a loop, I let the user ask a question, and then it invokes this agent workflow, and it keeps on doing the multi-turn interaction between the generate agent and the reflection agent until it reaches that limit of 8 or the 4 interactions, right? So let me run this and see how it works. So I'll ask, where is Eiffel Tower? So it will say Eiffel Tower is located in Paris, France. The critic agent says the response provided is accurate and concise. To enhance the answer, consider adding more information about Eiffel Tower, such as its history, significance, and architectural features. You could also include interesting facts or statistics about the iconic landmark to make the response more engaging and informative. Additionally, consider expanding on the location itself. So it gives some critic, which is given to the generate agent. So next iteration, it's the generate agent is saying the Eiffel Tower is located in Paris, France. It was uh, designed by Gustave Eiffel. So since it says adding more information, it's adding more information, right? So it is becoming more elaborate, right? And it will continue. The answer will get enhanced for 4 interactions between the agent and the reflection. And the final answer is this, I think it is the generate agent. Yeah, this is the final answer. So from one line, it actually elaborated the answer like this. So that's what I wanted to show today. That's what I wanted to talk about today about reflection agent. So this is a very basic reflection pattern. There are other reflection patterns in subsequent recordings. I'll talk about those patterns well. Thank you.